Oh. Okay, 6.2, average value of a function. All right, let's take a look at a relevant function, I suppose. Lately, temperature has been kind of changing a lot, especially because it rains a lot, right? So then it's kind of been cold during the day. So let's just say that this is T, meaning the temperature, and we are in degrees Fahrenheit. And let's say this is 50 degrees, so it's kind of cold, and this is 100 degrees, which is in the summer. So lately, it has been pretty cold at night. So let's say that this is 0 hour, meaning 12 a.m., and this is 24, which is like 24 hours later. So let's say that it starts, around 12 a.m. We are about 40 degrees or so. And then it kind of stays like that until the sun comes out. The sun comes out, it gets a little hotter. And then about, afternoon, like right now, or not right now it's 9 a.m. In the afternoon, it gets a lot hotter, but probably around 70. And then once the sun sets, then it gets colder again. And then it goes back to kind of the normal temperature. Okay, so the question is, what is the average temperature for the day? What do you think? If you look at this graph, okay, so talk to your partner, where do you think the average temperature is for a day like this? Rachel, can you be Arlena's partner today? So what do you think? So talk to your partner, what do you think is the average temperature for this day? Kevin, talk to your partner. Kevin's like, yeah. All right, what do you guys think? What's the average temperature? 55? 50?
65.
Okay, let's just say maybe around 55 or so. Okay, so that's kind of the average temperature. You can kind of see that it kind of crosses most of the temperature, or like around there, right? Okay, now if we have to actually find a number without just eyeballing and guessing where the average value is, normally we would think something like this, T average. We would think like, take the temperature at the first hour, temperature at the second hour, and so on, and then we add up all 24 hours and then divide by 24, right? That's kind of normally how people think of the average. You add up all the numbers, divide by how many there are, like your test grades, right? So you add up all of your test grades, divide by how many there are, that is the average. However, this is not real life because our temperatures don't change on the hour, right? Like it's not like 9 o'clock is just 50 degrees. 10 o'clock, 60 degrees. And then we just jump. Does that make sense? So temperature is a continuous function. If you go from 50 to 60, it has to go through 55, right? So then we cannot use this kind of calculation because it's not discrete, meaning your points are not 1, 2, 3, 4, 5, like points terms. So we have to think of something else. Okay, when we add up all the numbers, we're dividing by 24, which we can think of this as the change in this entire thing, which we can just say this is, let's say delta x. This is how much it moved. Or we can just say this is A and B, and then we know that according to Riemann sum, delta x is B minus A divided by how many numbers there are. In this case, because it's a continuous function and it's going to be infinity, because there are so many temperature measurements we can take. So we can actually think of it like this. we can just say this is T1 plus T2 plus ... to infinity, because we are not just taking temperature measurements on the hour. We could take it on every minute, and n gets really large, right? So we are going to divide by n, however many measurements we actually took. Now, if you look at this, we can solve for n. So delta x times n is equal to b minus a. So n is equal to b minus a over delta x. Okay, so then this is going to be T1 plus T2 plus ... all the way to Tn divided by b minus a over delta x. And simplifying this fraction, we get delta x times T1 plus T2 plus ... Tn over b minus a. Okay, sorry, I think I wrote my delta x wrong. Delta x should be, should be just the length of a little part of it. Okay, now if you think about it.
We have two delta x's?
Oh, sorry, I need to erase that one, everyone. It is now not erasable. Okay. So now, if you think about it, delta x times t1, delta x times t2, delta x times tn, delta x is this small part, t is this y part. If we add up all of these things, we are just looking at the area under the curve. And when n goes to infinity, we are just looking at the integral. Does that make sense? So we can just say that the average value of a function, let's just finish this part. So this part is really just the integral from a to b. And so we can just say it's 1 over b minus a of integral a to b of t of x dx, if we're talking about temperature. Okay, again, this part, this numerator part, is just the integral, or the area under the curve, and then we're dividing by b minus a, which is how long that interval is. So this is the equation you need to memorize. The average value of a function is 1 over b minus a of the integral from a to b of f of x dx. So if you have this function, you want to figure out where the average is, you find the area under the curve and divide it by the length. So how long, what is the length of that interval? Are you guys okay? Okay, now let me ask you another question. 55 is about the average of this function, right? So let's look at the area under this curve. The area under this curve is like this big. Is there another place where if I draw a straight line through and I multiply by the same width and the height of wherever I choose, it will actually equal the same area as the area under the curve? Is there a place, if I draw a line so that I create this box, that this area is the same area as the area under the curve?
Yeah.
Of course, right? I can always find that line. That line is the average of the function.
Oh, nice.
Does that make sense? Yes. Okay. Kai, thank you for your encouraging words. Okay, so the average value of the function is equal to 1 over b minus a and blah, blah, blah. So we can think of it this way. If I multiply both sides by b minus a, It's equal to the area under the curve. Right? So whatever the average is, if you multiply by the width of the function, it's equal to the area under the curve. So there's always this point that makes that work because it's a continuous function. Obviously, it has to be continuous. That is like the basis of all of these theorems. All right, this is called the mean value theorem. We did mean value theorem for derivative. This is the mean value theorem for integrals. This is going to be the last theorem we do this year, which is number 5. Yay, we're done with all the theorems. And then you're like, I don't remember any of the other ones. I know. Of course, I will prepare you for the AP test. All right, so let's look at one example. Find the average value of the function of 1 plus x squared on the interval -1 to 2. Okay, well, let's look at it graphically so we know what we're doing. This is 1 plus x squared, so that is the parabola that looks like this. From -1 to 2. Maybe I should draw my parabola. Oh, I cannot draw it anymore. So maybe something like this. So from -1 to 2, where is the average? I'm going to say maybe around here. I don't know. Looks about the average. So what you're going to do is use the formula. F average is equal to 1 over b minus a times the integral from a to b of the function. Okay, for this question, what number is b? 2, and then what number is a? -1, so plus 1. Okay, from -1 to 2, and then what's my function? 1 plus x squared. All right, so this is an easy integral. So go ahead and do that. Figure out where is the average value. Okay, so the average value, so go ahead and just kind of integrate this. So this is x plus x cubed over 3 integrated from -1 to 2, or evaluated from -1 to 2. And this is going to be 2. Good? Easy. So this section is not very hard. It's just applying these formula. Let's try another one. Okay, so do it by hand. Find the average value of sine x on the interval pi over 6 to 5 pi over 6. So the average value is 1 over 5 pi over 6 minus pi over 6 integral from pi over 6 to 5 pi over 6 of sine x dx. Okay, so this is going to be 1 over 4 pi over 6, and then this is negative cosine evaluated from pi over 6 to 5 pi over 6. All right, I'm going to simplify that fraction. So this is 3 over 2 pi negative cosine of 5 pi over 6 plus cosine of pi over 6, plus because it's minus. Okay, so this is 3 over 2 pi of 5 pi over 6, negative pi over 3. So it's going to be, negative square root 3 over 2. So square root 3 over 2. Pi over 6, so square root 3 over 2. Okay, that's going to be 3 over 2 pi of square root 3, which is 3 square root 3 over 2 pi. All right, let's do 2 more problems. Okay, the next one is just like the previous one that you did. Okay, 1 plus x squared. But this time, I want you to figure out what is the value of c that satisfies the mean value theorem. So it's the same question, except you need to figure out the value of c that satisfies the mean value theorem. Okay, so what does that mean? You have this average value that you found on the previous example, which said was 2. 2 is equal to what? Okay, so 2 is the average value in the function. what x value will give you this y value is the question. Okay, what x value will give this y value? So that is just make it equal to the function and solve for x. Does that make sense? So let's look at this graph. 1 plus x squared from -1 to 2. So this is 1. Okay, we know that the average value is at 2. So that tells us that if we draw a, if we're finding the area under the curve from -1 to 2, it is the same as the area under the curve if we draw a rectangle at 2. Right? The question is, what x value gives you that 2? What x value will give you 2 in the function? So just make 2 equal to the function and solve. So 1 is equal to x squared, x is equal to -1 and +1. Meaning at -1 and +1, meaning at -1 and +1, the function will be 2.
Where's the value of c come from?
Value of c. Okay, value of c. So according to the mean value theorem, f average is equal to f of c. Let me make sure so f average is equal to f of c, and then c is the number you had to find, which is the x value that gives the average value.
So does it mean like c is the x value that is at the middle? Like, so c is the average?
No, c is an x value. This is a y value.
So it means like at which point the...
Yes, at which x point will you get the y value?
Okay.
Okay, this week I think I'm just not explaining very well in every class. Sorry. Okay, let's try a problem. For this function, 1 over x, between 2 and 5. Okay, be careful on this kind of question. 1 over x. 1 over x has a asymptote, right?
Yes.
At where?
0.
0. So if they give you something where the interval covers 0, you have to be careful and then just tell them that the average value does not exist because it's not a continuous function on that interval. Okay, they sometimes give some tricky questions like that. So remember to apply the theorem, the condition has to work. The condition is always that this function is continuous in this interval. Okay, 1 over x is not continuous, but within 2 to 5, it is. So it's fine to use the theorem. But you do have to check the condition to make sure you can use whatever theorem you want to use. Okay, so the first one, find the average value of the given interval. Okay, you know how to do that. B, find c such that f average is equal to f of c. Okay, so go ahead and do A. If you're stuck on B, I will help you. All right, A. Find the average value of f on the given interval, so just apply the formula. 1 over 5 minus 2, integral from 2 to 5 of 1 over x dx. So that is 1/3 natural log x evaluated from 2 to 5. Let's see. 1/3 natural log 5 minus natural log 2. You can probably call it done at that point, or you could simplify this a little bit more and do this if you kind of forget your log rules, kind of quick recap. B. Find the value c so that f average is equal to f of c. Okay, f average is this number. It has to equal f of c, 1 over x. So just use your calculator and solve. X is equal to 3.274. Okay, let's look at part C together. Sketch the graph of f and a rectangle whose area is the same as the area under the curve under the graph of f. Okay, 1 over x. And that looks like this. From 2 to 5. I don't know, approximately here. So the area under the curve is this one. They want you to draw a rectangle that is approximately the same area as the one under the curve. It has to happen at x equals 3.274. So x equals 3.274 is around here, and it's going to hit the curve there. That is the average value. So this is f average. And then if you draw a box with f average as the height and then between 2 and 5, that rectangle will give you the same area as the area under the curve. Are you guys okay? Okay, it's just kind of, this is kind of the basic idea, and then your homework is going to give you a lot of like out there applications. So if you have any questions about the homework parts, let me know. But this is it for the lesson, 6.2, average value of a function, easy stuff. And then next week we'll start the next section.